in this video, we're going to take a look at the properties of the transpose of a matrix. In the previous video, we saw that the transpose of a matrix can be obtained by rewriting the rows of a matrix as columns. Let's let A and B represent matrices such that the following operations are defined. In other words, matrices A and B should be of sizes that will perform the following operations. First, look at the operation A superscript T to the power of T. This property is called the transpose of a transpose. And if we have matrix A and take the transpose of that transpose will be simply equal to A. In other words, suppose we have matrix A, we'll let it be a 2 by 2 matrix with row 1 and 2. Here, the transpose of our matrix would be 1, 2 for the first column, 3, 4 for the second. Now the transpose of the transpose, that is A to the T to the T, is equal to 1, 3 for our first column, 2, 4 for the second. And as you can see, that's identical to the original matrix. So that property, the transpose of a transpose, let's look at another property. And actually for this next one, I'm going to go to a new screen because I think we'll need more space. The second property says that matrix A plus matrix B, taking the sum of matrices A and B, and then taking the transpose, is equal to A transpose plus B transpose. In other words, we have matrix A, which I'll call 1, 2, 3, 4, and I have matrix B, which I'll let be 5, 6, 7, and 8. If I add A plus B, and then take the transpose, A plus B equals 1 plus 5, which is 6, 2 plus 6, which is 8, 3 plus 7, which is 10, 4 plus 8, which is 12. Now since we want A plus B transpose, next we rewrite our rows as columns. 6, 8, 10, 12. Now let's see if this is the same as when we take the transpose of A plus the transpose of B and take their sums at the end. So here, now let's calculate the transpose separately. So transpose of A gives us 1, 2, 3, 4. Transpose of B equals 5, 6, for our column, 5, 6, 7, and 8. Now if we take the sum of these matrices, we get 1 plus 5, 3 plus 7, 2 plus 6, 4 plus 8. And as you can see, these two matrices are the same. So that's our second property, that the transpose of A plus B is equal to A transpose plus B transpose. We have another property called, so this property is the transpose of a scalar multiple. This is our third property. And it states that our scalar multiple C, in other words, some constant, times A transpose is equal to C times A transpose. So if we let C equal 3 and A equal 1, 2, 3, 4, then CAT equals, we take our C and multiply it by each entry, so we have 3, 6, 9, and 12. So taking the transpose of our matrix multiplied by our scalar, where C equals 3, now we have 3, 6, 9, 12. Let's see if we get the same result if we take the transpose first and then multiply the scalar. So for A equals 1, 2, 3, 4, we have row A, or row 1, turning into column 1, row 2 turning into column 2. Now if we take our scalar multiple, we'll have 3 times our matrix, 1, 3, 2, 4, 3, 9, 6, and 12. Which is identical to our previous result. So this property holds. Let's take a look at our last property, the fourth property, and this is the property that states we have the product of A times B and take its transpose. This is equal to taking the transpose of B times the transpose of A. So again, let's let matrix A equal 1, 2, 3, 4. We'll let matrix B equal 5, 6, 7, 8. Product of matrix AB, this gives us 19, 22, 43, and 50. This can be found, this product, using a graphing calculator or working it out by hand, as was shown in a previous video. Now let's take the transpose of A times B. So A, B, transpose equals 19 and 22 for the first column, 43 and 50 for other columns. For the second column. Now let's take the transpose of B times the transpose of A. So here we have B transpose. That's going to be equal to 5, 6 for our first column, 7, 8 for our second column. A transpose is going to be equal to 1, 2 for the first column, 3, 4 for the second column. So now taking your product, which I'll do using a graphing utility, also equals this fourth property holds, and this one is called the transpose of a product. This concludes our example. Hope you found it helpful, and we'll see you next time.